At first, it's easy to assume the EV equivalent to the combustion engine to be the electric motors. But in reality, while there's no direct equivalent, it can be more useful to consider how the battery is a closer match. Welcome to a One Finite Planet EV video on which is the engine, battery or motor. Producing this video at this time was triggered by someone raising with me a comment by Peter Navarro on the engines of EVs being the batteries. Putting aside the politics, where the disagreement seems to be about whether Tesla is a vehicle manufacturer or vehicle assembler, rather than the role of the battery, which is the focus here. It's common to think of EV equivalents to fuel tank, engine and gearbox as being battery, motors and nothing. But there are several problems with this model. An arguably better model, as examined in the following chapters, is to consider the battery, in addition to the role of fuel tank, also performing the main role of the combustion engine, and to consider the electric motors as more equivalent to a gearbox. Consider the role of a combustion engine. Whether the combustion is internal or not, combustion is a chemical reaction to unlock chemical potential energy through a chemical reaction and produce power. Combustion is a chemical reaction as shown, and it can be argued that the combustion and being a source of power are the key functions of the engine. However, while the combustion is what first produces the power, it isn't all the car engine does. The power first produces heat, and then the engine converts a percentage of that power into motion, which is why it can also be described as a motor. The power rating of the engine is the amount of power converted into motion, excluding any heat not converted into motion. Batteries do, like fuel tanks, store the chemicals that hold the chemical potential energy, but they also, like internal combustion engines, use a chemical reaction to produce power. The chemical formulas for combustion and an LFP battery are shown here. The power of an EV is ultimately determined by the power the battery can produce, which is determined by the discharge C rating for that type of battery and by the size of the battery. For the same battery type, double the size, double not just the storage, but also the power, as covered in the video on the tech behind the BYD Shark. For any given battery technology, there's a C rating for charging, which gives the fastest time to charge, and another C rating, which provides the fastest time to discharge and determines the maximum rate of providing power. Divide 1 hour by C rating to get how long to charge or discharge. Doubling the battery size, either by doubling the number of cells or the size of the cells, will result in a double-sized battery that takes no longer for a full charge, despite a full charge having twice the total energy. But the implications for delivering power can be more important. Power discharge C rates tend to be higher than charge C rates, so moving the example to 3C power discharge rate gives 90 kilowatt of max power for the smaller 30 kilowatt hour battery, 180 kilowatt max power for the 60 kilowatt hour battery. This is why EVs with small batteries have low power. Again, for an EV, all power is from the battery. Although, just as with combustion engines, producing power alone is not enough, and there are extra steps needed to get the power to the wheels. The main reason an electric motor is not equivalent to a combustion engine is that electric motors don't produce power. An electric motor does nothing without a power source, and they deliver power by converting electrical power provided to them by a battery, generator, or both. The power output rating of an electric motor is only valid when combined with a battery and/or generator that provides sufficient power for the motor to then convert into motion. This is why EVs with small batteries usually have less power. Want a more powerful EV? The key step is to upgrade the battery. There are vehicles, like the current Australian spec Xpeng or Xiaopeng G6, which have two power specifications depending on the vehicle battery for what is basically the same electric motor. This is because not only is the larger battery a larger fuel tank, the larger battery is also an engine capable of producing more power, which allows the motor controller to be configured to deliver more power. Like gearboxes, the maximum power rating of an electric motor reflects the power it can handle and then deliver to the wheels. Controls aside, motors themselves are a set of magnets and electrical coils in a housing with bearings that, like a gearbox, simply converts whatever power is provided as input into motion that will rotate the wheels. Neither produces or controls the power itself. Also, like a gearbox, motors can handle maximum power even at 0 RPM, with the limit being the ability of the power source to deliver the power. For a combustion engine, power available is determined by RPM of the engine, and the gearbox provides for allowing the engine to produce more power even when the vehicle is moving slowly by providing flexibility between engine speed and vehicle speed. When an electric motor is powered in part or in full by a generator, as is the case with the BYD Shark 6, the system provides this same flexibility between engine speed and vehicle speed. Of course, batteries can already provide maximum power independent of vehicle speed. Neither the battery nor electric motors control the amount of power produced at any given time, with that role for motors being performed by motor controllers which incorporate inverters, and can be housed with the motors or separately. These could be considered the equivalent of computerized fuel injectors and control the amount of power drawn from the battery and sent to the motors. Considering the battery as equivalent to the combustion engine and as the main source of power can help understand limitations on when vehicle features can be used in an EV or plug-in hybrid like the BYD Shark. Both EV/EV hybrids and internal combustion ICE vehicles have both a high power, only running sometimes power source, and a low power, running all the time power source, which exists only so there is some power available when that high power is off and to start the high power. With an ICE vehicle, the main power is the engine, and without it, it is not only that the car can't be driving, there is also no air conditioning, hydraulic power for steering, or hydraulic brake boost. With an ICE vehicle, it's quite obvious why the combustion engine is not always running, but it can be surprising to find that with an EV, usually when parked, the main battery gets switched off and completely disconnected, which is why EVs also need to have a low voltage battery, just like ICE vehicles. The reason the main battery gets disconnected is it's either a battery with lethal voltage levels or that powers circuits with lethal voltage levels. So it's much safer for the main battery to be off than on. While there'll be a separate video linked below on the subject of running a fridge, etc., suffice for now to say that to play it safest and avoid risks from everything from falling trees to system faults, manufacturers switch off and disconnect that main battery whenever possible. This usually leaves the main battery/engine off and the lower non-lethal voltage system as the only power available when the vehicle is parked. Most vehicles have an on switch, but just as with modern ICE vehicles that have a remote start allowing the vehicle to warm up without anyone getting into the vehicle, the main battery, that is the main EV power and equivalent of the engine running, can be on even when the switch is off. To run mains power from vehicle to load, to charge the EV battery, to run air conditioning, or even to recharge the low voltage battery, the EV will turn on regardless of any switch settings. Yes, for a BYD such as the BYD Shark, just plugging in the VTL adapter actually switches on the main power EV engine battery. Hope all of this helps, and if it does, give it a thumbs up and look out for more. If there is a specific topic you would like covered, including the engineering behind how things about EVs work, please indicate that in a comment.